All right. Hello, welcome everyone to my presentation. Today we are going to talk about Foreman and provisioning with the boot ISO. My name is Stejskal. I'm Red Hat developer for 5 years, I guess. Together with my team, we are mainly responsible for the registration, provisioning, compute resources, and other stuff that is happening about, all this fun. We also have some integration with the Ansible, Puppet, some cloud resources, but that's not a topic for today. So, what we are going to talk about? We have some introduction. We will talk about provisioning in Foreman, of course. So I'll show you what capabilities we have right now. Then I'll show you what the boot ISO, what it's about, some workflows that I prepared to show you, and something here. Yes, there are going to be some last notes before the questions and answers. I forgot to replace that one. All right, so provisioning Foreman. Who is Foreman user here? Okay, most of you. Who is involved in provisioning? Okay, everyone here. Nice, nice. All right. Good to know. So, networking provisioning, Foreman images. As you probably know, or might not, we are pretty big list with network provisioning. We have bare metal virtualizations for the libvirt, VMware, Pixie, grub, BIOS, UEFI, you name it. Recently, with the great help from the ATIX guys, we also have the secure boot. I think it was not released yet. We are still testing, right? 3.14. Okay, it will be in the final bits, yes. So there's plenty stuff to coming for in next release. And for the Foreman images, we already have Foreman boot disk and Foreman discovery. I'll show you details later on. So with the Foreman boot disk, who is using Foreman boot disk for provisioning here? 1, 2, 2.5, I see, okay. All right, so there are basically 4 images that you can generate with the Foreman boot disk, but I'll talk about those 2 most important, which is full host image and the subnet image. Basically, these ISOs are generated by us. With the full host image, when you create host in the Foreman and you click generate full host image, we'll create ISO that is specifically per the host with configurations for the syslinux and grub2, and it includes some bootloader files, and it's also pointing directly to the Foreman. So it's downloading Kickstart and all the stuff to your Foreman machine. Also, the kernel and init RAM disk is synchronized from the media or from the repositories, depending on if you are using Catalog or not. And the size is somewhere around 160 megabytes. For the subnet image, what we do is that we generate the ISO with the syslinux grub with the ipxc and grub2 configuration files, but the config files are pointing to your subnet where you have the smart proxy from where the Kickstart will be downloaded and the provisioning will start. Foreman discovery. Who is using Foreman discovery? 3, 4, 4.5. All right. So with the discovery, the biggest feature or the most important feature is that when you boot from the ISO, the image will boot, and after some configuration, it will call to the Foreman and it will appear as a freshly discovered host. From there, you can create the host, set up some configuration, or you can assign the host group. And when you create the host, we will trigger the provisioning, and with the kexec command, we will start the installation of the host. This could be very useful, for example, when you don't want to create the host first and then boot from the ISO. When you are running around and booting machines, you can boot the machine, it will report to the Foreman, you can do the configuration in the Foreman and provision the machine. So now, boot ISO. Boot ISO is this. I think I copy pasted from the Rocky documentation or from Alma Linux. That could be CDN, HTTP endpoint, or Foreman. So that's what it is. That's in the documentation. The good thing is that Fedora, CentOS Stream, RHEL, Rocky, and Alma, they both has this image. So it doesn't matter which OS from this list are you're going to boot. It should be working for everyone. I'm not sure if Debian or Ubuntu have something similar. I see something saying yes. Zero experiences. I don't know. So, but I'm looking forward to hear some details after the presentation. So, I apologize in advance, but I'm going to talk about today about mainly these OSs. So, what's inside? We have grab2 and some configuration files. There are some FEI images, init RAM disk and the kernel, some ISO Linux files with the configuration, and install a runtime environment for Anaconda. I don't know what this means exactly, to be honest. I tried to check the details, but I didn't find anything, so really don't know. So something for Anaconda, for the installer.
Anaconda, basically Anaconda is a full-blown operating system. If you start Anaconda, you actually start a full operating system, and then this operating system needs to know how to parse Anaconda scripts and kickstart script and everything. So that's the runtime environment.
Oh, cool. So now we know what it is. The difference between the boot ISO, which has around 1 gigabyte, and the full ISO that has, for the RHEL, it was around 6 gigabytes, is that with the full ISO, you will get all the RPMs from the upstream and base OS repositories. So this one, when you boot it, it needs to download later on these two repositories, all the data, so it can boot and install the machine. So maybe you ask, why another one? If we have Foreman discovery image, if we have Foreman boot disk, 2 images, why to introduce another one? So the obvious thing is that it's provided by the OS maintainers, by 5 OSs, and it's one of the way how to install the operating system officially, So as you know, Foreman is maintained, developed by the Red Hat, so it would be shame if we won't have any support for it in the Foreman or in the satellite. So pretty simple reasons. For the challenges that we have right now is that maintaining, updating, fixing issues for all the ISOs, it's quite taking resources. The testing is problematic because what is happening is that sometimes customers are like, hey, I have this HP something, and it doesn't work. And we're like, Like, we don't have that machine, we don't have that environment, so it's kind of really difficult to maintain it. So testing is very problematic. But we have also customers in past who just send us the hardware and we were able to test it. So that was nice, but it's the problem. And in quite a lot of places, we are using tech preview features. For example, the kexec that was never officially supported by Red Hat, from what I heard. And for the cases, what we are doing there are like hex for hex in the hex. So yeah, it doesn't work very well in, let's say, in 100% cases. So that's the reason why I want to start thinking and implementing the boot ISO provisioning in the Foreman. Now, mkksiso. That's the tool that we are going to use today. It's a very simple tool for creating Kickstart boot iOS. In its simplest form, you can add a Kickstart to boot ISO. Yes, it's very simple tool to use. It's a part of the Lorex package, so you just need to install one package. And we will use 5 arguments today for achieving our goal. So first, obviously, we need some input ISO, which is going to be stream, Rocky, you saw the list. The output ISO, that's going to be the name of the ISO, and these 3 arguments. Just want to say that the tool has obviously way more things, you know, it's not just these 5, but for today's presentation, we really do care just about these ones. The first parameter is going to be add, that allows us to add our files and our directories for the installation, so we can then later on use them in the Kickstart or, in the Kickstart. Command line for editing grub and ISO Linux configuration files, and obviously the Kickstart file that we are going to use for the provisioning. Few things before continue. The whole system architecture needs to match. So if you want to do something for x86, you need to do it, you know, on the same host, and you need to be root or user with a sudo when you change customizing the ISO. And that's all the preconditions. This presentation is on GitHub, so all the commands, Kickstart files that I'm going to use will be there. After this presentation, I will also export it to PDF, and I will upload it there, so you don't have to watch the whole video again. All right. I forgot to mention we are going to talk about 3 scenarios that we have right now, and the 4th one that's going to be, let's say, in the future. I call it future ideas. The first 3 are right now. You can do that with the latest Foreman, even the older versions, without any code change, anything. That should be working out of the box. For the 4th one, we will need some developer work, but it's going to be easier than when I was planning it. I was thinking that it's going to be very difficult, but so far it looks like for the first proof of concept, it will be just one new API endpoint. So I hope that won't be that much work. So for the first scenario, I call it minimalistic and static. It's basically just for the playing around to see how does it work, you know, what it does. So yes, useful for testing and playing around. Or one interesting point was that it could be also for the case when all the configuration is done later on with the Puppet or Ansible or your favorite tool. Basically, the idea is you have minimalistic Kickstart, you provision the machine, you play Ansible on it, and it will do the match. So I'll switch to my GitHub profile. I apologize, I don't have any demo, because every single time when I'm trying to do demos, something goes wrong. So this time was like no demos. So I will only have the configuration files, some README files, and these GitHub repositories. That's it. But I promise you it works. I tested it on my instance, and it works on my computer. So with the first scenario, what you only will do is run the... Is it visible from the... Or should I make it bigger? Let's make it a little bit bigger. All right, so as you can see, we just run the tool. We are passing the minimalistic Kickstart and input output ISO. That's it. With this one, what will happen is that in the grub file, that is a part of the ISO, we'll add this part in stage, where it is. Yes, Kickstart and the load from the, sorry, where it is? I don't have it. Oh, yes, sorry. It's here. Minimal stream case. In this scenario, what we will do, that we will upload the Kickstart, static Kickstart file directly to the ISO, and with that you can go with the flash USB stick and just upload the machines. I'll show you the Kickstart file. As you can see, it's very simple. This is not for the production, okay? This was for my testing, but I just want to show you that it's basically 20 lines, and I was able to provision the machine. Nothing more, you know? So it's very simple. Tested it with the Stream 9, but Stream 10, Stream 9, Rocky, Alma, it works all the same. As you can see, yeah, that's basically 3 steps. First, I need to remove the ISO, then I need to customize it, and this is my libvirt command for provisioning the machine. Now, let's go back to the provisioning here. So, obviously, doesn't do much. There is no Foreman, everything is static, so if you want to change anything, you need to rebuild the ISO and basically do it again, which is annoying. So, what we can do that make it a little bit better, we'll start using Foreman. So, I'll go back to my GitHub. Let's go to the workflow number 2. And what we are going to do with the workflow number 2 is that we'll use kernel parameter, but this time we are not passing the kickstart file template file, but the URL. In this, when you select the boot option, this will ping the Foreman. Foreman will respond if the host is in the build mode. We will respond with the kickstart file, and the provisioning will happen. Very important thing is inst.ks send MAC address, because on this endpoint, when Anaconda is asking Foreman, we search for the host by the MAC address and probably by IP address. There are some conditions, and if you'll miss this send MAC, we won't get the MAC address, so we will never find the host. So in this case, inst.ks and inst.ks send MAC is very important for making it work together with the Foreman. And again, it's just simple 3 arguments: command line, changing the kernel parameter, input ISO, output ISO. And that's it. With this one, you will boot, the machine will get the kickstart from the Foreman, and all that fun stuff will happen. Now, where we are. All right, so we have used Foreman, and we have finally kickstart template that is generated per the host. But it's still far away from the perfect state. So first of all, you need to create the host first, which might be a problem for someone. Would be very nice if the machine would report it to the Foreman, wait it for some time, and then you have still time to do your stuff. The machine also must be, the host in the database must be in build mode. Otherwise, Foreman will say, hey, this machine is not ready for the build, and will respond with 405. Now, yes, 4 or 405 errors. If you've seen errors from the Anaconda installer during the provisioning, they are not always nice. So if you will build the machine, it will ask Foreman, and let's say by accident you forgot to put the machine to the build mode, it will respond with 405. You get such a crazy error, and that's not really nice. So that's the stuff we can respond. Also, if you call the provisioning endpoint that is generating the KS, if the host is not found, aka it's not created in the database, or you don't have permissions to see it, we will respond with 404, which, I mean, it's okay, but I found it problematic because I don't know if it's the 404 is coming from wrong URL or host not found. Yeah, okay, so you can check it pretty simply, but it's annoying, So that could be improved. And also, right now we are in the record where there is 300 seconds timeout, and you cannot do anything with it unless you reconfigure the record. I'm not going to do that. I tried that, and no. So we can do it a little bit better. Basically, we take all the stuff from the previous workflow, and we add a new template called default NetBoot kickstart template. And what we can do is we could implement first kickstart template that would be just basically running in the loop, pinging Foreman and saying, hey, can I boot? And if the Foreman says, no, you cannot boot, it can wait until some timeout with some loop. And if it's fail, it's going to fail with some nice error saying, hey, I was waiting, let's say 30 minutes for the kickstart, got nothing, I'm turning off the machine. So how to do it? We'll go to the scenario number 3. And here I have my very proof of concept kickstart that will point to the Foreman as before, and in the while loop can ask the Foreman for the kickstart and catch the errors. If you get a 404, if you get 405, we can just simply say message, and we don't have to put the stack trace. I mean, the stack trace makes sense for the developers, but when you got response 404, I don't need, stack like this one. Yeah, it's coming from this Python function. I don't care, it's 404. The good thing is, the most important thing, is that once we got the response 200, what we are going to do that we are going to save the output to a special new host.ks file, and in the end we will run this, include root host.ks. This will, I forgot to say one thing, right now all the stuff that I mentioned is in the pre section. This is from Anaconda. So in the pre we have our script that doesn't have to be bash, it could be a Python. So but for this presentation it's a bash, and this is running in the pre. Once we get the template from the response, we will save it. No, wait a second. Here. Once we get it, we will save it to the file, and we include the file. So now we have 2 templates. The first one to somehow tackle the problem of I'm starting machine, but the machine is not ready in the Foreman. So here it's waiting for the amount of the seconds you want. And once it's ready in the Foreman, it will get the template, it will run it, and it will install the machine. Now, let's go back to the slideshow. Just want to mention all of this is possible right now. You can test it with the Foreman, works out of the box, or should be working, But what we achieved? We are catching finally this host states. We are getting nicer errors, customizable template with the parameters and the content. Timeout, I gave up around 20 minutes. I don't know what's the final timeout, but it's definitely more than 300 seconds. I was just, okay, but 20 minutes, that's enough. And we got a little bit better user experience. Now, problems. We still have some problems. The biggest problem that I found out later on is that we were executing the loop in the pre section. And when you ask Foreman for the main default kickstart template, if the template is including pre section, it will be skipped. So in the second phase, you cannot have kickstart template with the pre section because you cannot execute pre in pre. And that's from Anaconda. That's how it is. So you have to rewrite it. The other thing is that the default boot kickstart is still in ISO. What we still did is that we have some file that is in the ISO, and if you want to change it, you need to rebuild the ISO. So yeah, we improved the workflow a little bit, but still stable. And we still have the problem with 404. Like, we still don't know if the not found is because the host is not existing or there is something with our URL. We still don't know. The future. Since this moment, it's really like future plans, so that's not working with current Foreman. Get the new template from the Foreman. All right, so instead of including the file to the ISO, we can create a new API endpoint that could be called, let's say, NetBoot template, I don't know, or something more original. And the workflow would be simple. You call the Foreman, and Foreman will respond with the template, with all the logic for the loop, waiting, and so on. And in that template, it will call then second Foreman for the final kickstart template. With this one, you get the option to configure all the templates directly in the Foreman. You can add the permissions and everything for the endpoint. So that should improve it. I hope so. But the ultimate goal is that right now, if you want to customize the ISO, you need to download it somewhere. And if you are, for example, who is provisioning RHEL machine? Red Hat Enterprise. All right. There is no right now, or at least I don't know about it, there is not easy way how to download the ISO without signing to the customer portal. That's annoying. So what we could do in the end is to have workflow where you prepare everything in your Foreman, host parameters, kickstart, host group, so on, and have simple forms saying, I want to provision this host with this ISO, this operating system, let's say on libvirt, and just click provision, and it will automatically download the image. It will automatically customize all the parameters required. If you want to point it to specific smart proxy, that could be included. Assign it to the host, operating system, make it available from the Foreman so everyone can download it. And if you select some compute resource, let's say libVMware, that can boot from the ISO, it could do it. We have all the data, we have all the parameters. So this is the ultimate goal. But more realistically, in the upcoming versions, I would like to focus a bit on this workflow where we add the one endpoint and allows user to start the NetBoot ISO with different. So that NetBoot template could be in the Foreman, that endpoint would be generating the template.
So we already have that. The unattended provision, basically, we have the unattended public endpoint, which is basically the same, where you can specify the name of your template, as long as the template is marked as public from type public, you will be able to actually download it even without Foreman credentials.
And you don't need the host ready for provisioning.
You don't need anything. You just download it.
See how it works? All right, so basically tomorrow it will be ready. No, okay, I didn't know that because, I was thinking that you always need some host. The reason for the first call is first to have Foreman in the Foreman template so you can edit it in the UI, and also the restriction with the host in the build mode. If that's not true, as I was thinking, then nice, we have one less work, so it should be even easier to implement.
Obviously, that being done at the moment involves the CfgMgmtCamp template called the Foreman find name mkxiso host, which will then basically try every single interface and throw out in the MAC address and everything to help Foreman find the host.
Also, we can skip the part that when we know that the host is already ready, it doesn't make sense to download one template and then pull it again. We can directly pass the kickstart and it would work. Yes, definitely. What is not here is that, as you remember before when I was talking about the Foreman discovery image, that's the path where I still need to do more investigation. But the idea was that if you start booting the machine from the ISO and it's not ready for Foreman everywhere, it could report it just some basic facts like MAC address, IP, something like that. And you could from there start the provisioning process from the Foreman. But that's something I need to investigate more. Didn't have much time to take a look. But definitely, this is something in the future that we would like to implement in Foreman.
Anything that can do a HTTP post, you could just post basic info to like a fax endpoint or something. I know there's HTTP ways to submit that information today, because there has been since I used it 10 years ago.
It's still there.
It's still there. It's still there. I never tried to collect the facts in the press section in the Kickstarter installation. I don't know. I don't know how does it behave.
Something as simple as like
Yeah.
IPXE, the basic boot.xyz image, gets all
Yeah.
the IPXE info anyway. I mean, all the MAC address info and all that anyway.
MAC address, IP, that should be fine. Yeah.
From that.
Yeah, that should be available. Yeah.
Be very careful with EFI firmwares because you can easily break things like secure boot, and you are relying on the base firmware that you have on your
That makes sense.
on your NIC. So if that is not implemented correctly, or again, if you do want to use secure boot, then all those things will actually
Lots of
be
edge
wrong.
cases.
Yeah.
I was just more thinking about the way of submitting this. It sounds like something that's already there.
Oh yeah, it's already there. Yeah, submitting facts, that should be easy. The only thing that we need to do is create all the database structure for the discovered hosts and then converting to the hosts. But yeah.
I knew I was saying something. I just didn't know what.
All right. So I want to mention some last notes about what you can hit and what will you probably think about. So debugging. Kernel parameters for inst SSHD for enabling the SSH during the installation. Also the inst.debug increase the verbosity of the logging. With that one, I would be kind of careful because it can make the logs really annoying and big ones. So this one I would enable just before you are going to push the bug and send the reports, to the installer team. Like otherwise, all the errors what I got was perfectly fine without raising the inst debug level. So this one. Kickstarter helpers. Yes, these tools I have found very useful. They're coming from the PyKickstart package. First one is KS Validator. It does exactly what you think. It's validating the kickstarts and KS Verdiff, where you can see the difference, what has changed between, let's say, RHEL 8 and RHEL 9. Very useful, simple package. Definitely recommend to use it. Also, you probably noticed that I haven't used any make add argument for the make ISO. So I just have these slides here. If you want to add any files to the installation process, you want to have them ready in your ISO, you can use this argument. It will make the files available in the run install repo and name of your directory. It could be useful for the certificates when you want to have secure connections, or you can add your custom repositories from that directory. Check the documentation on the web page. It's quite very simple. Secure communication. I did my best, but I was not able to make HTTPS connection from grub when I was asking for the kickstart. It always switched to the HTTP with self-signed certificates. Somewhere in the deep of the internet, I found few years old Red Hat answer that was saying, oh yeah, it doesn't work. And that was it. I don't know if I'm really bad at Googling, but it was kind of surprising that I found only one answer hidden behind, Red Hat's account saying, oh yeah, it doesn't work. And no details, nothing, so if you were able to make it work, I'm really looking forward to hear your, how you did it, because for me it was impossible. But during the installation, you can certificates or your certificate in the prep post in the kickstart. Since Fedora 42, there is a certificate command, so you can use that one, official way how to edit. Or before, when I show you the add dir for the maker also, you can use that. Or tofu, trust on first use. You basically do the first call as a HTTP, and in that response, you can get the certificate, and for other connections, you can use it. The choice is yours. And when you boot the OS, you can, first of all, as I said, with the add argument, you can add your repositories, and or you register the host back to the Foreman, or you use Ansible Puppet for the configuration. Questions? Yes?
Does what you were describing work with the 4OS variants?
Good question, for which I do not have answer. I would have to look.
Functionally, it seems like it's the same setup, but instead of Kickstart, they're just not using Kickstart. They're using the other thing that I just blanked on.
Oh yeah, should I?
So just for the recording, I was asking if it works with the CoreOS variants, since they're not Kickstart based, but functionally it all looks the same.
I don't know. I'm sorry. But I will take a look because. But I will take a look. Any other questions? Alrighto. In that case, if you want to talk about provisioning and everything, I'm inviting you to our booth that is downstairs. We are starting Foreman provisioning in this group called Speak. The name is going to change probably, but we are really looking forward for your, provisioning stories, because our plan, or my plan, is to build a strategy for provisioning in Foreman. And basically, if you tell us that there are some very useful tools that could be useful also in the Foreman environment, or if we are missing some support for, let's say, libvirt or stuff like that, I'm the person. We are owning, not part together, we are working, and Shim, forgot to mention Shim, we are kind of owning the provisioning component in the Foreman, so if you want any improvements there, we are the persons to go. Thank you.